Welcome everyone to the bi-weekly Parquet Sync meeting. So we start the meeting. If you're new, I think I see a few new faces. We start this meeting by going around the room. I'm going to look at the people tab, and usually that means we're going by alphabetical order from first names. And so each person who I call your name, can you quickly state your name? Correct me if I'm pronouncing it improperly. If you're comfortable sharing where you're working and what you'd like us to talk about today, and we'll build the agenda from there. And it's perfectly fine to just want to be a fly on the wall and just listen in. So on that, I'll start. I can start. I'm Julien. I'm a principal engineer at Datadog, and today I listed a few follow-up items from the previous meeting that we might want to talk about. The discussion over the new footer. I think we had some discussion about interval types. Just wanted to check if we want to talk about it. And I think another topic was the process to adopt new encoding. So I had written that down as follow-up from last time. On my list, the first person is Alex Steven.
Let's try that again. Hey, everyone. I'm Alex. I am an engineer over at Google. I'm just kind of beginning to work in this space. So I'm here under invitation from Talat. Just really looking to be a fly on the wall and kind of start to immerse myself in everything that's going on.
Welcome.
Thank you.
Next, I have Aditya.
Hello, hi. I'm Aditya. I'm part of CMU's variants team. I'm here to listen.
Alkis.
Hi, I'm Alkis. I'm an engineer in Databricks. I'm working on the Parquet Databricks, or partially, and I'm working on the new footer. And want to give an update on the experiments we have done on the flat buff footer in Databricks.
Nice. Thank you. Andrew.
My name is Andrew Le Dem. I'm a staff engineer at Influx Data, and I am working heavily with a bunch of other people, including the CMU variant team, to try to get variant in the Rust implementation. And I'm mostly here to listen. I don't have any specific topics for today.
Brian.
Hey, I'm Brian Hewlett, also from Google. Nothing to add to the agenda, just here to watch.
Dewey.
Hi, I'm Dewey. I'm Whereabouts, and I'm working on Parquet and geometry, mostly in C++. I'm hoping to get to Rust soon. Yeah, mostly just geometry.
Talat.
Oh.
Talat.
Oh, sorry. It's too fast to receive me. You know.
Sorry. Yeah. So we're in alphabetical order, except it puts the name of your room in the alphabetical order. So you go before your turn.
Okay. My name is Talat. I'm working for Google. You know, I work with Brian, Alex, and I don't have anything as agenda. I just had the action item from last meeting. Besides of that, I don't have anything else.
Okay. Jeff.
Hey, I'm Jeff. I work at Snowflake. Follow-ups on the footer and encoding stuff from last time, but nothing new other than that.
Martin.
Hello, Martin Promer, Carnegie Mellon variant team, working with Andrew and Aditya. Nothing particular to add here, just fly on the wall.
Meng.
Hi, I'm Ming. I'm from the Scan and DML team at Snowflake. Nothing to add to the agenda, just listening this time. Thank you.
Prashant.
I am from Snowflake, just here to listen. Yeah.
Pratik.
Hi, I'm Pratik. I'm a part of the Scan team at Snowflake. I'd really like to hear more about the process for the new encodings and the footer experiments.
Russell.
Hey, I'm Russell. I'm also at Snowflake. I'm here mostly to see some discussion of the new deck flow proposal, which I'm sure Thomas will talk about in a few seconds.
The new what proposal? Sorry.
I don't want to steal Thomas's steam, so he'll tell you about it.
Okay. Sounds good. Sai, and please correct me if I'm saying it wrong.
Yeah, I am Sai. I work for Snowflake. I'm here to listen anything related to data types in particular. Yeah, thank you.
And Sandeep.
Hi, I'm Sandeep. I work for Snowflake as well. I'm here just to listen, learn, and learn about encodings and footer information here.
Good. Selçuk, and please correct me if I'm saying.
Yeah, this is Selçuk. I'm an engineer.
Selçuk.
That's okay. I'm an engineer at Snowflake. I mostly would like to follow up on the process for adding new encodings. I thought we will see a document on that at some point, so I would like to see where that is.
Selim.
Yes, hello. Nice to meet you. So I'm here today for a very specific question, which is how to go about detecting partition fields and partition values from a partitioned file using the Java API. It's a very specific question. And also, I need to know how to get the modification date for a file using the same API. Thank you.
Okay. Thomas.
Hello. So I'm another software engineer from Snowflake. And I'm here to introduce you to the new decimal floating point type proposal we just sent around last week. The thing that Russell meant. So.
Okay. And last is Vinu. Oh, Vinu is saying I'm in transit, so I can't talk live. But I'm Vinu, building a new startup and just listening in. One thing top of mind, I bumped 3 to 022. It's not published in Maven Central. Okay, I'll track that down, update in the PR. Okay, so we'll have to check that. Thank you for joining, Vinu. So on the discussion, so we have the follow-up items. We have the specific question on the date. I think regarding we talked about the process, but Micah is not here. So I'm not sure if we're going to be able to make progress on the definition of the process today, unless someone else wants to pick up on that and update on where we at. And so maybe, I guess besides the follow-up, we have two things, right? We have Thomas, the proposal you were talking about, and we have Selim's question for the how to get detection of partition field and last modification date. I think on the, so does someone have an answer on top of their head? I think Selim, your question might be better on the mailing list to get an answer on for that kind of question. But unless someone has an answer on top of that, I don't. Right now, I don't know exactly what's the right API to use.
So do I need to formulate the question through and send it through the mailing list?
I have a feeling that's going to be the most efficient way to do this, as opposed to discuss it live on the meeting, just to get all the details. And I think that's be a better way to get an answer to your question.
Okay.
Right. Thank you. Okay. Do we want, so let's move to so we have the DeckFloat Parquet proposal. Let's start. So maybe let's start with the Alkis. You want to give an update to the new footer? Let's start with that, and then we'll move on to the encoding discussion. It's just I have a feeling that the encoding discussion will take more time, so it's kind of put the updates first and the discussion after. I think is a good way to approach this. Does that make sense? Like, if you disagree,
I'll try to be quick.
Okay, let's do that.
Thank you, Julian. So we have a prototype now running in Databricks Fleet under Shadow. So Shadow means it's not this new footer is not written anywhere. And what we measure is how much time it takes to deserialize this footer after we encode it in memory, and compare it with how much it takes to deserialize the same footer in Thrift. We also wanted to capture the difference in bytes, but there was some configuration issue, and we don't have that data yet. We're gonna get it next week. But from the deserialization, we have some results. Now, to give some background, what we did here is that we have a different representation of the footer in flat buffer. And for compatibility reasons, we take this flat buffer, decode it, we build the same Thrift object model that you would get if you decode the Thrift protocol, because it's easier to kind of do the migration this way. And just building this Thrift object model in memory takes quite a bit of time. It takes more time than deserializing flat buff or verifying the offsets, but it's still faster. So in our experiment so far, we are in a small percentage of production, and we see that the deserialization speed is improved by 30% on average. More importantly, is that we see that for the pathological cases, the ones that are very slow to deserialize the footer, we improve by 80 to 90%. So that's 5 to 10x speed up. There are some regressions that we're trying to get examples of and understand why we're regressing by roughly 20, 30%. So the next steps for us is to get these regressions and understand why and fix them, and also get the number of bytes that are used in the flat buff versus the Thrift representation. We expect that we're gonna have big wins there, up to 2 to 3x reduction. And from that, we're gonna infer how much faster we're gonna get the fetches to get the footers in the system, because if they're smaller, you typically do less fetches to fetch the footer. Most engines are doing a single fetch, a speculative fetch of some number of bytes to fetch it, and if they miss, they do a second. So if you make the footer smaller, you're gonna get more volume of footers with the first speculative fetch. So once we have the data for the bytes and we fix the regressions, and then we're gonna put everything in a doc and make a proposal, and then we're gonna start discussing here with the details. Any questions?
What parts of it would make flat buffers smaller? I mean, Drift like variant encodes integers and does all this stuff. And flat buffers is kind of notorious for bloating.
Yes.
String lengths and all this. So I'm a little
So
surprised.
there's a bunch of tricks there. So one of the tricks is that we make some offsets relative to start of row groups. So you don't have offsets of 8 bytes. And a lot of other small tricks with types and stuff. And in the end, we LZ4 compress the flat buff. And because the vtables of the flat buff are kind of mostly the same, they get compressed really well. And in the end, what we have is something that actually beats the thrift by a large margin.
It's not an apples to apples comparison, right? Because what Alkis did is not just convert from thrift to flat buffer. He also took a look at the data we were putting in there and having a better representation of it.
Okay. And it's also LZ4 compressed. I mean, I guess like the pathological cases, we would probably expect even more than a 10x speed up if that wasn't compressed, right?
Actually, you would spend more time fetching if you didn't compress it. The pathological cases, if you didn't convert the flat buff to thrift, it would actually be even more than 10x. The biggest chunk of time in the profiles that we have in our micro benchmarks is taking the flat buff and creating this thrift object model so that we can feed it in the engine because that's what it reads.
Okay.
So, and it's just a temporary, over time, you would not need that anymore, right? So you port all the code that depends on the thrift structure to use directly the other format.
Exactly.
You would not need that anymore.
So you are deserializing everything right now. It's not selective deserialization of columns based on what you're scanning.
Yes. And if we do flat buff, we will reduce the deserialization time dramatically because even though we'll be deserializing the whole flat buff, deserializing flat buff means checking all the offsets that are in the bounds of the byte buffer we have. It's not really doing any other work.
Hey, Alkis, like probably a new question, but like as a part of your footer reading and parsing, a lot of time is spent just in their network, sending in that request, getting the data, and then you deserialize it. So until unless your footer is like super large, I don't know, like let's say 1,000 columns, that's when your size reduction and parsing will achieve that. I think 80% number is what I remember you mentioned. So is the experiment geared towards those larger number of columns, or are you seeing that kind of a benefit for smaller number of columns also?
We see it for smaller numbers, but the 80 to 90%, we have to check if these are the white column cases. But these are the cases where they take a very long time to deserialize in thrift, and we see that they get like 10x improvement to deserialize in flat buff.
Got it. Awesome. And this is including the LZ4 decompression.
Yes, the LZ4 is like, it's very small compared to everything else that is happening.
Got it.
Also, there's a question from Pratik. If we're seeing multiple fetches for the footer, this is the telemetry we didn't manage to get. I'm gonna have it next week. So in the next update, I can talk a bit about that. So just to touch a little bit on the shallow experiment. So here we're not testing reads at all. So this is when we write Parquet files, we take what footer we would write, we convert it to this new representation, and then we do a transformation back to the thrift object model and compare that everything is good.
Okay.
And we get the numbers. So we're not going to observe any benefits in the reads yet because we're not writing this thing. The reason for not writing is that we expect that we're going to find improvements. We're going to make improvements. If we write it, then we need to deal with upgrading it. But if we do shadow, then we don't have to do this. We can change the format without having to think about migration.
Got it. Interesting. And just for clarity, like you are when you are encoding, you're using not just doing the footer, but the column indexes also, or is it just the footer?
This is just the footer.
Okay, got it.
So I guess like for the decoding step, which I know you're not doing yet, but in theory, like if we're compressing the footer, that's, you know, in order to reduce the number of IOs going to the object store or whatever, that seems like it's kind of the optimal thing for an object store. But if you're storing the file on like a local SSD or NVMe or in RAM, and you know, you already have the footer cached. Is that a case that we need to consider for performance as well, or?
So one thing we're adding, one of the regressions is that this is a very small footer that compression doesn't actually do much for it. So we're gonna add a flag to say if it's compressed or not compressed, or you know what codec we use to compress. So we can make it store uncompressed footer as well. If they're tiny, it doesn't really make a lot of sense to compress, especially if compression doesn't provide benefits.
Okay, yeah, that makes sense, and I think it would provide flexibility for users to make a decision, you know, for their use case. If they want to be able to do kind of random access into the footer on disk representation, or if they want to have to decode the whole thing.
Yeah, I think this will be up to the writers. What we're looking for here is to define the format and demonstrate that this format can actually provide substantial benefits to the existing.
Okay. So I think the other thing, so thanks Alkis for all the updates and the analysis on the performance. I think the other thing we need to do as a community, so I linked the PR in the notes. I'm going to send it there, that you had posted with your prototype, and it details, if you go in there, so that's PR, it's on Arrow, it's in the C++ side of things. PR 43793 on Arrow. It details the various assumptions and things that Alkis did. It was like maybe sometimes limiting the size of a row group or things like that. And so it'd be nice if, or also, I think you remove also some metadata that was deemed not necessary anymore or duplicated.
Yes.
And things like that. So I think it would be really nice if people will have different implementations, like, you know, a different proprietary implementation of readers and things, to take another look at it, to make sure that, you know, obviously Alkis verified that on the data set that Databricks has access to, that it makes sense. It would be nice if others were doing that as well, to have more, to start building consensus on, okay, yeah, all those changes are fine, and this is what we're going to do, right? And thinking of what are the next steps to validate that we're going to do that. Because there's the performance aspect, and then there's a functional aspect that they are modifying slightly some of the functional characteristics, right? There's some small limitations being added on how big some certain things can be with the new footer.
And a caveat here, the prototype we're testing right now is a little bit different than that PR, but not substantially so.
Yeah, and maybe I think
I'll try to update this PR.
Yeah, okay, that sounds good. Yeah, I think that's important, because we need to get to the point where we can get consensus on, yes, we want to adopt this as a new footer. So that means we need more eyes on, and people like signing in blood that, yes, we're going to adopt this and integrate this, our engine or something. So I think that's a big improvement to Parquet, but we need to make sure, yeah, we can get to contribute it in. Okay, so do we want to move? So I see a note. I think on the process for adopting new encodings, we'll follow up on the mailing list.
Yeah, I'm really sorry. these things, 2 weeks seems like such a huge amount of time, and then it just comes back around, and I have nothing to show. So I apologize. It's not in a great shape, but I'll like do whatever polishing I can tonight and share that so that I'm no longer a blocker for this stuff.
Okay, yeah, and I think we have from last time I had written down people who were going to take a look. So Selchuk, Jeff, Talat, Micah, and Alkis, right? So it's kind of the list we had made from giving feedback to this. So good. That's fine. I can change this meeting to every week if that helps. Moving things back. Yeah, thank you, Russell. Right, nothing's happening in the next 2 weeks that would keep any of the people in this meeting busy. Right, that's true. Okay, so do you want, Thomas, do you want to take it and talk about your proposal?
Sure. So let me share my screen. So, I'm a bit unfamiliar with Google Meet, so give me a second. Okay, I think everybody should see it. Perfect.
I see you, Doc. Yeah.
So what I want to do is that I want to give you some kind of a high-level overview to the new decimal floating point type we're proposing for Parquet. And of course, invite everyone to give it a deeper review in the doc. So somebody already did it, but a lot of others are still missing, I assume. So what is a decimal floating point type? So if you look at numeric type systems, for instance, the one of Parquet, then we see two different ones here. Those are mostly fixed point numeric types, so which are all integers or decimals. Those have the advantage that they provide very exact computations and also representations of the actual values they represent. But they have a very, very small or limited range to offer. Another one that everybody is most probably familiar with are floating points, binary floating point types. So they're mostly called float or double precision in most programming languages. So those provide this very or much higher range compared to the fixed point numbers, but they have a problem with exactness. Yes, so exact computations, exact representations are not possible here, as those are mostly some approximations of the actual value. So if you look at certain industries, for instance, the financial one, then you have other demands there. They need high range and exactness. And exactly for those things, we have decimal floating point numbers. So those are mostly available in most of the programming languages we have. They are available in database systems like Oracle, DB2, and so on and so forth. So Snowflake is also about to add one. So in programming languages, most of you are most probably familiar with Java's big decimal. This, for instance, is such a decimal floating point type. So are there any questions so far before we go to some details of the design?
Yeah, go, Micah.
Yeah, sorry. Are there any? So I understand there's like, in language representations for this. Are there any like open source query engines today that support DecFloat?
We know that Spark supports such a type, which internally uses a big decimal. But for the other ones, we couldn't find an example yet. So
okay, but doesn't like Spark just do like fixed decimals?
as it also supports the decimal type, which is backed by a big decimal. So
But I thought that like gets serialized to like we already have like fixed decimals in Parquet, right? And this is something like where precision and scale are fixed. If I understand correctly, this is same thing, but scale like effectively like the scale like is variable per value.
exactly. So the difference between fixed point and decimal floating point is that you don't have the static scale, but you have the scale encoded in each value.
Yeah. Okay. So, but yeah, so I thought the decimal type in Spark, and I'm not a Spark expert. Still learning.
I'm also not. So.
Yeah. So I think that might be like the main thing to address, just in terms of adoption. Like, if this is proprietary only, like how much use do we think we will see from it? I'm guessing Spark will need to do it eventually, right? Like,
so if you have it available as storage engines, this also paves the way for getting it into these engines one day. So that's the thinking that we have, at least. So you have it available in all programming languages, either in the standard library or by external libraries. And as we see, this becomes more and more popular. Customers are also asking for this, and this is what motivates us to bring this into the standard and also enable those open source engines to support it one day. So,
okay. Are you proposing this to Iceberg as well?
this is our idea, yes.
Okay.
Okay. So as already mentioned, so the difference between fixed point and decimal floating point is mainly that we encode the exponent here additionally to the significant. So for fixed point, you usually have the significant, and your data type knows the scale, so there's no need to encode this separately. We also made some considerations here of what range that we most probably need by looking at all the things what other databases support and so on and so forth. It's also worth to mention that there is a IEEE version of this, which is the decimal 128. So this is an IEEE standardized decimal floating point type. So we should also emphasize that it's not something proprietary here. So, but the problem of this type is that it's not covering the precision that we actually need to have a wide support for all database systems. So, and also of what our customers think they need, for instance. So yeah, so the type just looks, we have significant and we have the exponent, and also this normalized flag, which helps us to speed up some computations like so frequent operations like hash operations or comparisons. So this is something like a hint that should help us to speed up things.
Andrew?
I'm sorry. Have you considered using decimal like 256, like a wider type? Would that satisfy your use cases? Like
decimal 256 is also IEEE specified. So well, I know there's one thing in Arrow, but
yeah, that's where I'm coming from. Like from the arrow bend, like it's already an arrow, so
Arrow, I think it's a fixed point type. So
still fixed point, yes. But you got double the bytes to encode your values in. I'm just curious.
It's a fixed point type, and we actually need a floating point one, so that well, the naming is indeed confusing. Or am I getting it wrong?
My question is, if you had like for the use case of whatever ranges your customers think they need to store, right? Would a 256 fixed point decimal type work, or does it have to be floating point?
It needs to be more. Yes. Needs to be floating point. For instance, you have, so just to name one example, we have for cryptocurrencies, you have very small numbers sometimes, for instance, just to have put one use case on the top of your mind. So it's not supporting the range that we actually need.
I'm wondering, what range do you actually need?
The range we exactly need. I think I did not put it here, so I need to look it up, but I can tell you what the decimal 128 has for a range, which is from -6K to +6K. So this is the IEEE one, for instance.
Yeah, but I think to what Andrew's point, I think it's like a valid question. Like, you know, with the 256 fixed point, like, and this is kind of what BigQuery did to, I think, solve something similar. You actually get 76 bits of precision, and 38 bits of scale, and the question is that, and we're saying that 38 bits of scale is not sufficient for some use cases.
So the scale for the scale, it's okay if you have this scale, but the problem with the scale is that it needs to be per value. So you usually have a high variance in the where the scale should be within those values, and you also want to utilize your significant bits of digits that you have as good as you can. For instance, if you want to do a division of whatever, divide 1 by 3, and then you see you get a lot of 3s, and the decimal floating point type, you could put 38 of them in there. In such a fixed point type, you can only use it based on your data type that you have, which defines the scale. So, does it make sense?
Well, I mean, I think we're asking for the practical difference in some of these cases. Like I understand that there is in theory a wider representation for floats, and like the scales can vary a lot, but a certain
Every practical thing that customers don't like is to specify a scale. This is one huge pain point. You don't have to do this for decimal floating point types, for instance. Just to name one pain point. Yeah.
Right. I will stop like picking on this, Sandra. I don't know if you have anything to add. I think it's just the question of like customers don't like picking a scale, but like if you pick the scale for them, I mean, this is exactly what BigQuery does. BigQuery has a notion of big numeric that is just a really wide fixed point decimal, like essentially fixed point decimal width there. So like you do lose some precision in like some very, very niche use cases, I guess. But I think the question is weighing that versus the other things.
Another disadvantage of using such a wide type simply is also that you waste a lot of bits, because a decimal floating point type just leverages all the digits it's got if needed. If we say, okay, we use a super wide type just and encode it there, then we most probably waste a lot of bits and bytes in there to just store zeros. So you can compress it, but at some point in time you will have it in memory, and that's not a good idea. So.
Well, it comes with trade. Is the another way to say it. Maybe we can just add a section to the doc. I'll put a note in there that we can say some other ways that have been considered and sort of why the proposal is superior to those in certain areas.
Is it really 18 bytes or is it 17 bytes? It seems like there's was it 15 byte? Was the BIOS exponent 15 bits or 16 bits?
The BIOS, as the exponent, it's 15 bits. Yeah. So we can represent.
Bytes. Yeah. Okay. In terms of storage,
-16K to +16K. So
yeah. Are there
should be
other
more than sufficient?
Yeah. Are there other representations for serializing that we've considered, or like it's not clear to me what encoding schemes would work well with these types of things if we're like packing a bunch of fields together.
But let's discuss it in the doc, I would say. So I just wanted to give a high level overview today. So. But thanks for your question, of course. Yeah, and that's mainly it. So we already talked a bit about how that could be mapped to other programming languages and engines. So we see a lack of support in open source engines. Yes, that's true, but it's something that changed in the future. I think that's all from my side. So.
There's some talk a while ago about Parquet supporting extension types to make things like this like very easy to prototype and yeah, so like it'd be easier to like show the difference or have an example with the difference in a Parquet file before adopting it into the official type system. I don't know if that proposal went anywhere. I think Antoine said he was interested in working on it as well.
Yeah, I think he lost a little bit of steam on it, but I think he put up a pull request. But that's also an interesting idea.
Yeah, I think in general, it's good to make it easier to experiment with such things, right? Like, and I guess as part of Micah's doc that is posting later today, we talk about how we make the decisions, right? Because there's always a trade-off of adding more things to the spec versus making it more complex. So we'd have to have a good way to decide that.
Even coming from the variant side and what we've been looking at for prototyping implementations, there seems to be a really great use case for types that are possibly relevant to a variety of use cases, but not necessarily generally usable. So, like, for example, with the decimal floating point there, like the decision to not have nans and infinities represented in it is a very clear choice that will map well to some systems and it won't map well to other systems. And so you kind of run into the situation of, for these more specialized cases, it'd be really great to have a central framework. I mean, I don't want to, we want to keep it compact, and so it's focusing on just the extension types alone and then maybe building something on top of it could be really interesting. But this is almost starting to touch where within other particular file formats we're looking at, there's talk of like having embedded WASM modules to handle encoding, decoding. And so you just completely shunt that expectation off from the file maintainer side to the user side. Because in the case of the decimal floats here, like you're going to now have to ensure compatibility with those decimal floats and all of the readers and writers and exporting it to particular languages. And if a certain language has a big decimal that requires nans and IMS support, that's not a headache per se, but it's putting burden on the maintainers to be aware of the nuances between the implementations. And it's like, how does Parquet line up with that? I think I really do believe that more types is better. So I'm coming from a biased perspective there, but you can't include everything. And so if we could just like focus all of that effort of cool types, well, for lack of a better word, into just a very controlled area, I think that'd be hugely useful for not just, because what, this is variant, this is the geospatial that Dewey, you've been working on. You've had some problems, I think, with the extension type with it for an issue. I don't remember if that got addressed yet, but on the Rust side anyways. And then DeskFloat now. So it seems like we're all kind of converging to, we would really love extension types to be more powerful.
I mean, I think you could encode this in like a fixed length byte array, right? It's just that everyone would kind of have to know, oh, this 18 byte fixed width byte array is actually DeskFloat, right? So I think there's kind of a balance between putting that responsibility on the reader versus kind of or the engine versus building it in the spec to some degree.
Yeah, I mean, the way arrows may be the best example of this, right? Like, so most new types that get added are added as extension types, and there's like things that are like canonical extension types, right? Which prevents everybody from needing to like implement them at once. So it lowers kind of the burden to entry, right? So you agree on the convention that says our logical annotation type is like extension, and it has a string identifier that says DeskFloat on it. So it's really a question of what things you want core to the spec and what things you're willing to let people kind of decide on their own.
Yeah, the next thing I think is like min max would be different, right? Like if you start in a fixed length byte array, right, the min max are different, than semantically you know that it's a decimal number encoded in a certain way. And then the other thing is the encodings would, you could do a delta encodings that understand this, and take the two halves of the numbers and encode them separately or something. And then something like that. The other thing I was thinking is like this design, like takes some, like you were saying, Martin, right? He decides there's not going to be not a number coding. There's not going to be, we're going to have, this is the right number of bits for the exponent or something. Like all of this, they could also be parameter of the type, right? Like of whether it's all normalized or not normalized. I mean, you have a bit to say whether it's normalized. It feels like we could have and maybe I'm overthinking this, but it could be a more generic definition of this. And in the type definition, you say, hey, we take that many bits for this. We encode this that many bits for this information, and and this is how it's encoded. And so that there's less the trade-off on compactness versus constraints of the range can be like, because otherwise we have to think really hard. Like you say, oh, Oracle wants supporting more bits for the exponents, therefore we should probably support that so that we cover everything. But then if someone else come up and say, oh, you know what, now we need one more bit because we're storing spatial data and this is the size of the universe. And
there are indeed a lot of encodings around for this one. So.
Anyway, maybe it's overthinking the thing, but it feels like there could be a slightly larger framework.
I think there's also like runtime performance considerations that go into the sizing. Like, if we did like 111 bit, and then 17 bits over here, then that's just going to be like really annoying from an implementation perspective to have to deal with all these various widths versus aligned sizes, or reasonably aligned sizes to what the computer instructions do. I think it's a factor we need to keep in mind as well when specifying how flexible it is, right?
Yes. But like, for example, adding one more byte might not be like, it's kind of, I agree, like 128 is not arbitrary, right? It's aligning on a certain size. That makes sense. But the rest is kind of fixed. Okay. Yeah, go ahead, Kiss.
I have a question on the normalized bits. From water cooler discussions with HFT friends, performance changes a lot if you know that all your decimals are normalized versus not. I didn't read the proposal here, but do we have a mode where we say all the decimals I wrote in this column are going to be normalized, so you don't need to check every time?
So we don't think of such a mode, no, because it's pretty easy to check such a bit. So that was the motivation to not have it at a more coarse-grained level. But also something we could discuss, of course.
Okay, from your experience, you're saying this checking the bit doesn't cost too much.
Decimal floats are usually a bit, computations cost you a bit more, so not always. So they have a huge variance in the performance there. So,
but if you're doing some join and you're hashing and you're doing equals, if it's normalized, you don't check any bits, you just go blind. And you're probably using SIMD to do that. Checking bits in SIMD is expensive.
Checking bits in SIMD is expensive, yeah. So should please rephrase the question? So I'm not sure whether I get it. So
I think it's adding a piece of metadata in the type that says, hey, it's all normalized anyway, right? So you know
which speeds things up. So.
Or alternative question is, if from your experience, normalizing is not expensive, why don't we write...
Normalizing is expensive. Because you have to do a lot of divisions, you don't know how often you have to do it. Then you have to shake type bounds of the exponent and so on. It's a non-trivial thing. So.
Okay.
Nothing I would recommend to do too often. Cool. So, but if you do comparisons and you have this 128 bit significance, so I don't think that there's much you can simplify. So if that was a question.
To chime in a bit here, having looked at decimals from a research perspective a bit, Thomas, you have done a really great job here of threading a very fine needle of exactly what you need for what you're kind of hoping for this decimal format to do and what you don't need. And so that care and consideration is definitely present with it. It's just everyone here in the room can think of a pathological example of where you run into headaches, etc. So we would rather have schema and force normalization. We'd rather have very particular rules for the sizing. We want padding, etc. I think I really like Julian's idea of this almost build a decimal builder of your schema defining it, and you pick out all your parameters yourself. Like, I think it's sort of this way of you cannot make everyone happy with it. You'll always find a headache point somewhere, and that's just a compromise you have to make. Like, this is having spent time with dinosaurs of professors, as I'll generously call them. These discussions happened back in the 60s, 70s, 80s, when a lot of the original IEEE formats were put together and people were deciding what exactly they want, what they didn't. So it'd be worthwhile to open up a longer form discussion on this exact proposal of what are the things we particularly want, what do we don't, and what should the Parquet and really just this whole space have an emphasizing for this decimal type be. There could be a thing here of the Parquet implementation has significant differences from the Arrow implementation, just because they hit two completely different marks. Of Arrow's going to want to have really good compute with it. Parquet might want generality or storage efficiency, anything else. So I mean, I don't think anyone really looks forward to having a series of meetings of let's hammer out the most minute details of our format and have 30 to hour-long topics of disagreeing on very specific points. But for a format specification like that, if you don't have a generalized way to build it, like I really like build a float workshop. I'm just thinking of like those mall stores that have the teddy bears you can build yourself. It's floating point format. I think that's hilarious, but I love it. I think it's, without belating the point, this will need a whole lot more discussion with it. But the proposal as it stands, like, this is really clean. This is cool. It's a good way to start.
Thank you.
Okay. So we'll follow up on the conversation in the document. And then following up on the other discussion on how do we adopt new types like this. And so there's a few things we need to follow up on. There's the whole discussion on the extension types. There's how we adopt new encodings and new types. I think this type in particular falls in that category. And the discussion on what exactly the constraints are okay for this type of type. Okay, that sounds good. Thank you for presenting this today.
Welcome. Looking forward to get all of your reviews. So.
Thank you all, and we'll see you in 2 weeks. And enjoy the conferences for everyone who celebrates.
Bye-bye.
Bye-bye.
Thanks, everyone.